Hi, and welcome to the New Space Vision podcast, sponsored by LiveView, where we chat about new space technology, finance, and innovation with executives, founders, and more exciting people from the startup and new space ecosystem. I'm Daniel Seidel.
And I'm Sam Shivara, and together we are the founders of the Earth observation company LiveView and New Space Vision. Today's guest is Max Gulde, our friend and CEO of Constellr. Backed by an impressive array of investors, Constellr is planning a sophisticated constellation of thermal microsats with incredible high resolution to optimize water usage in the agricultural sector. And these satellites, of course, are supported by Constellr's own data platform. And we're very excited to hear more about that. But first, welcome, Max.
Hey, welcome, Sven. Welcome, Daniel. Thanks so much for having me here. And I wasn't sure if I'm invited because I'm executive or just interesting new space person. Hopefully, interesting new space person.
Yeah,
you are both.
You definitely are.
And actually, in the background of this podcast, where I'm really happy that we're sitting together right now because we tried it multiple times, like 3 times, and always was coming in between. So really good that we're sitting together now.
I should have managing my calendar. I'm sorry for that.
All good. I just came into the office 2 minutes prior to the podcast starting because I was at the other event, but that's a different story. So before we talk about Constellr, obviously we know one another since quite a few years now, but on your LinkedIn profile, it says that you started out your career as a physicist. So can you tell us what brought you to the new space industry and what have you been doing before running the show at Constellr?
Yes. So to make it very short, what brought me into new space was A, frustration, and B, claiming things which I couldn't hold. So overpromising basically. So what happened? I studied physics. I built microscopes for about 10 years, looking at really, really small scale structures, graphene, and built the first microscope which could actually resolve atoms moving in real time on a single atomic layer. That was nice and nifty. And I always hoped that someone would come and pick up that invention and revolutionize whatever cancer research. And obviously nobody ever did that. So at some point I was like, that's interesting, but it's also really frustrating. So what do we do? Also, to be frank, I felt relatively early on that I didn't have the mental capacity to really move the needle in physics to make it blunt. I'm just not smart enough.
And if you, it's not the first time I hear that from a physicist and from a person I think is very smart.
That's nice. Our board member, Christian Reitberger, who has a PhD in quantum physics, also said that, right? He was working at the CERN.
So he was probably smart enough to move away. Now I can also claim that I'm smart enough to move away, but actually I was not smart enough to stay. So after building these microscopes, I was like, okay, what else can I do? And I thought, okay, if I want to do something, I really want to do something where I can feel good about for the next, 10, 20 years. So what's the big challenge I can contribute my time to? And the big challenge for me was climate change. So I thought, okay, what do you need for climate change? You need an outside picture, which for me was very clear as Earth observation. Otherwise, it's difficult to get an outside picture of climate. You need a lot of, back then it was probably more labeled as big data. So number crunching capabilities, AI, whatever you call it. And the last thing is probably robots. I love robots. I do Mars execution. So I had the advantage of having zero clue in any of these fields. So applied widely, got rejected a lot, and eventually landed a job at Fraunhofer because the person who interviewed me had even less of a clue than I had. So the physicist, obviously, super cool person though, helped me a lot and taught me a lot. So I then started tackling problems at Fraunhofer, and this is in the spacecraft technology group. So this was the first time I was touching the realm of space and Earth observation. I solved a lot of problems which have already been solved, just not knowing that they had been solved. Invented a lot of stuff which is pretty useless, but some stuff which is a tad useful. And amongst the other, a lot of things I did was designing a space mission, and that really sparked the love for space. This technology is so amazing, and I'm pretty sure that the future of humankind is not just on Earth; it's on Earth and beyond. So I was like, okay, I want to be part of that. Plus, it kind of checked all the boxes when it comes to climate change and so on. But the thing which was really frustrating for me was that things are moving slowly in research, really slowly. And if you put in 150%, it doesn't matter, or if you put in 75%, it really doesn't matter. So I love if there's a correlation between how much you put in and how much you get out. And yeah, this was the first part. So this is how I ended up in space. Now, how did Constellr come to be? There was a project with BahnBW, and they want to have a satellite which does nifty things for the Bundeswehr in the end. So I was asked like, hey, let us come up with a couple of nifty things. And we brainstormed a little bit. In the end, it was rocket detection. So in the end, we kind of promised rocket detection on a very small satellite. And then I was really proud that, hey, that's it. It's a from a single CubeSat, from a useless application, but it's a nice proof of concept. You learn a lot and so on. And we overpromised big time. So in order to detect the rocket, you usually don't detect the rocket itself, but you detect the plume, right? So the exhausted gas, so heating of the atmosphere. And you need to have very precise temperature measurement to see that heating. And that simply couldn't be done. So, but since we promised, and I was the mission scientist, they said, hey, solve that. And then I tried to come up with things, how to make that precise measurement on a small platform. Once we did this and we patented the approach, I was like, okay, that's quite interesting. But this is a completely, I mean, it's a useful application, but it's just such a niche. And there's actually already solutions for that. But you can apply this for urban heat islands, for agriculture, for all kinds of defense security and innovation, for all of these things, industry monitoring, activity monitoring, early warning in crop stress, all these things, even wildfire. So why do we just use it for that absolutely single niche application? So I then said, hey, I'll get us some money. Again, boasting a bit. I'll get us some money, get us some grants, and then we can do proper stuff. So together with Marius, one of my co-founders, the other one is Chris, we wrote, with the course of a bit more a year, 14 applications, and we were denied 14 times. So we didn't get a single euro. And at some point, our boss told us, like, hey, our bosses actually, that's really nice that you like writing applications, but we even nicer if we would do a single euro of return of invest. Because you guys are expensive. And then we said, yeah, okay, then we do it ourselves, right? We met Chris at this point in an accelerator program, and people told us, like, that can't work. The patent won't go through. You have no clue, which is all correct, right? I mean, the patent did go through, but was we were clueless. And in the end, maybe out of, German would say tots, out of simply the feeling that, hey, we're going to show you. Yeah, we found the company and said, okay, let's just try it.
Amazing.
This was how I entered space.
That was like a great story. You mentioned you wrote 14 applications and all were rejected. To which organizations did you send them? What was that about?
Horizon Europe, for example, or Horizon 2020 back then, DLR. We spoke with all the ministries. We had so much stuff like national, international, mostly European level. And sometimes you got really good ratings, but we never actually made it.
That was 2018, 2019?
Earlier even. This was starting 2017. And I think the game changer was that we used part of that and then put it in the application for the Copernicus Masters.
Yeah.
There was a ESA Sentinel Smallsat Challenge. I think this was 2017. That's actually where we met in Tallinn. For the first time. You already existed. We didn't exist for another 3 years. And we wrote this application as just one of the things, and we kind of forgot about it. But well, this was not a real application. It was just like this game, this challenge. And then I remember we were on the way to vacation, and suddenly this Italian guy calling, "Hey, you're at the finals!" And like, who are you? Obviously, I said so Italian, so it was ESA. And we're like, wow, that's really nice. And in the finals forward, and so he explained us, and it's like, yeah, this is game changing. What you came up with. We're like, yeah, but this is not even on paper, right? There's a single PowerPoint presentation. That's it. There's zero substance. Yeah, it doesn't matter. And this is how we entered for the first time the ecosystem of new space, I would say. We then invited to the Copernicus Masters. But we didn't win in the end. I think we won it 2019, 2 years later. But, this was just amazing. It was really, really, really cool. And this is how we entered the ecosystem. And now I would say it was actually a pretty smart move to enter the ecosystem, even though I might not be smart enough for physics at academic level, but maybe I'm halfway smart enough to do this.
Says someone who published 58 papers, correct?
Yeah. But this is okay.
Yeah. Just saying. No, but I think it's very interesting because we consider ourselves being in the same new space wave with you guys, right? Robot Tech, also ESA Aerospace here in Germany, but it's interesting how times have changed. And today, right? I think if you write 3 applications, you would get 1 because everything is getting now strategic in our industry. But before we go into the company story, maybe can you share with us quickly the Fraunhofer spin-off story? Because I think under our listeners, there may be some people who want to start a company who are in research, actually in a similar situation. How was that?
Yeah. Single word, difficult. The second word, lengthy. But in the end, third word, successful. So we had different levels of support. My direct boss said, it's never going to work. His boss said, it's really exciting, but it's never going to work. His boss said, wow, that's cool. Try it. And his boss said, it's a shit idea, but I like you. So this was going through the institute. These were the reactions. Funny enough, number 2 from the top is now working with us very successfully. So that's cool, dude. So like, okay, mixed signals here. Then I heard from other founders. We went through a really good accelerator from founder ahead. It's a really excellent accelerator. And we heard from other founders. They're like, hey, it's going to be tough with a licensing deal. We're like, yeah, sure. But we're smarter, right? And this seems to be a common common subject. I was thinking that I'm smart and then discovering that I'm not smart enough. Then we said, okay, we create a term sheet and then we write everything down. We have full align with the institute and then we just hand it to Founder of Central and they just make contract and we do all this thing super fast and so on and so forth. So went to the accelerator, learned quite a bit. First time in touch with the business canvas and first time in touch with actually thinking about who the customer is, which back then was for me completely new perspective because it was like, why would you need a customer? It's an amazing technology. Stop the stupid talk about customers and market size. That doesn't matter. It's amazing. Don't you see that? Okay, you can see has been some evolution, not a lot, but some evolution. We then handed in the term sheet and the first call we had with the Fraunhofer lawyer was like, this is not market standard.
Yeah.
What part? I didn't read it, but it's never market standard. I was like, oh boy, that starts well. And then he's not working for Fraunhofer anymore, but he was able within a single call to really, I don't know, saw the seed of mistrust between the institute and us. Do you know how much they're going to pay themselves? Wow, they're going to be rich. You won't. You need to start milking that cow now. So it was really, do you know that if you give them these conditions, your career will be ending because everybody will know they have no clue what you do, right? Really nasty, really, really nasty. Fraunhofer Venture tried to moderate, but wasn't really successful. And then we went into a big fight, right? And we escalated all the way to the top. Back then it was Raimund Neugebauer. I'm still happy. I'm wearing this a little bit like a medal. It was either him or Kurz who told me that I'm the politically best connected asshole they know.
Wow.
That's about it. So we escalated it way up because we just didn't see how this would be working. Again, full support from the institute by then to a certain degree. And now that we are their biggest space client, a core partner of us, and it's working splendidly. With Central, it was really difficult. It took us 11 months to negotiate the first deal. The deal was still not good. And then we had 3 further negotiations. So in total, I think it was 2.5 years of negotiation. Funny story, until the end of last year, we paid €1.67 in licensing fees. And I'm not sure how many tens of thousands of euros this cost in legal cost or personnel cost. We spend, I think, about $500,000 in industry money, giving them orders, right? Because part of what they're building is now flying in our spacecraft. And this was a deal of 5 minutes, right? Oh yeah, we just do it, right? So slight imbalance.
Yeah.
But hey, in the end, it worked. I think the general hint, maybe a tip I can give to anybody who's doing this in front of, probably also DLR, escalate, persevere. It's part of what you need to do anyways as a founder in whatever capacity you will be in. And just don't give up, get support, get a lawyer from day one. And even though maybe the institute's people are your friends, don't think that everybody within that negotiation is your friend. And they have a lot of experience in the negotiations and you might not have. So be ready for a nasty fight. However, with Holger and Zelka, my feelings with a couple of discussions, things will change. I'm very positive about how things will be now at Fraunhofer. And it's also part of the signals I start hearing.
I mean, Fraunhofer, Max Planck are such important institutions for Germany, right? And they have so much potential for building great companies. So let's really hope that things are going in the right direction.
It was mind-blowing. So the companies we met there, I'm not sure how many were killed through the process of just trying to license our technology, right? But if only 10% of that technology actually makes it to the market, this has a gigantic impact. It's a massive innovation, ecosystem. It's great. And the people there are really friendly and nice and good researchers, but just the process is killing it.
But this podcast is about Constellr. Maybe we should make another one about the German innovation ecosystem. But for sure, Fraunhofer is now very proud of you, and obviously,
of course, we're always the best friends.
But as listeners maybe already have recognized, you have some interesting quotes, and one of your quotes is, today's Earth observation model isn't venture backable. Still, you've started a company which is venture backed and which is an Earth observation company. So we want to learn more about Constellr and what brought you to this statement. So what is Constellr doing? Could you tell our listeners?
If I would only know. Okay, what we're doing is we're building a layer of thermal intelligence. And initially, we have said this is very much focused on agriculture. That is true. That's how we started. But now we are cross-domain, like from security, defense, agriculture, urban industry monitoring, and so on and so forth, right? But there are big applications all across. So what does it actually mean? Imagine you have Google Earth, but Google Earth on steroids, having a real-time temperature digital twin of the entire globe. So why the heck is that? Give you a few examples. Every human activity on the globe has a thermal fingerprint. And you can see that thermal fingerprint and you can see how it changes over time. So it's all about time series. And I give from a couple of industries, give a few examples. Imagine you're looking at a power plant and you can actually see if they're starting a reactor, cooling down a reactor, if the production level is going up or down. This could be also a refiner. So super interesting to look at anomalies, which might be an early indication for, let's try to avoid a second Chernobyl. Funny enough, Chernobyl happened on my birthday, second birthday. So I do remember that date. The other thing is that if you look in agriculture, you are using for large-scale agriculture already today, you're using obviously satellites. But temperature data gives you about 2 to 3 weeks advanced warning compared to existing satellite data, and still about 12 to 14 days advanced warning when it comes to crop stress compared to someone who's standing in the field, right? So imagine 2 weeks earlier than your peer, your competitor, your farmer, whatever, this 2 weeks earlier what's going to happen. It's a massive advantage. If you look in urban fabric, so you're sitting in Berlin, I'm currently sitting in Munich, so maybe not the most prone cities for urban heat islands, but if you look at what let's say the global damage level of on the economic side from just urban heat in how it influences our productivity is going to cross $1 trillion in 2031. That's a big number. Because cities are not built very efficiently. Why? Because you don't really see how your mitigation effects are taking place, right? And I mean, you're probably closer to that use case than we are, right? So temperature is a core environmental variable. The problem is that we don't have temperature data at the right quality, which means resolution and frequency and accuracy, and then also latency. And that's what Constellr is solving. It was a very lengthy, not elevator type pitch, but just giving a bit of insight. And obviously also for defense intelligence, there are lots of applications, anything from tracking vessels, even underwater, looking at underground infrastructure, activities in hangars, all these things.
And this is super cool. We had one other guest on the podcast who was from Satellite View, the founder of Satellite View, and spoke also about thermal, but we're going to go into the differences between you and them in a second. But before that, so are you offering a data layer, which companies like LiveView can buy, which then have special domain expertise in analyzing this? Or do you offer a platform where people can make sense of it? Like, what is the customer ultimately buying?
So it depends who the customers, right? We start with data because data is the foundation of everything which comes on top of this, the analytics and so on. We do exceptions if we have a large enough ticket in reach where they say, hey, can you actually build a bit of analytics on top, be it a irrigation advice, be it monitoring of crop yield, be it early warning of anomalies in a certain frame. Then we can also do analytics. But ideally here, we usually partner with companies like you who have domain expertise. So we wouldn't try to rebuild something which already existing if it doesn't make absolute sense to do that. And most applications, as you know, don't rely on a single layer of data. Right?
Yeah, correct.
They rely on multiple layers of data. That's the whole background of your business model. You're merging these layers. But there are a couple of applications which are very strongly dependent. And here we could potentially build analytics. However, we are primarily a data provider for now, evolving eventually into becoming a more, let's say, downstream type of analytics turnkey solution provider. But this is in the future still. I skipped over one thing, the non-measure backability of Earth observation. So I'm very happy to explain that if you want, if you still have time for that.
Yes.
Funny anecdote here. I said that to one of the VCs while I was raising. And in that moment, once after I said that, I said, it's not venture backable. And then the internet connection failed. So it was a typical mic drop moment. It was like, wow, this guy has nuts. His balls, right? So it tells me that it's not backable and just closes down the video conference. So I called him again and explained it, and then things went well. So the problem is the following, and you might have seen that. You've seen that none of the single satellite companies, the operators, at least neither old space nor new space, have really succeeded to scale commercially. It's mainly a governmental business. For you, and I'm super happy that this is the case. I believe you're mostly commercial, mostly with exactly. Yeah. Nice. But if you look at the Planet Labs, if you look at all the others, the Maxars and so on, they're all government. So why is that the case? Because there's a linear correlation between how many revenue you can generate and how many satellites you need to have to do that.
Yeah.
Right? That is the big problem. imagine, and why is that the case? And the case is because we're usually looking at visual and radar, and this is a non-continuous variable. And I'm sorry, this is now a bit physics mumbo jumbo. What I mean is the following. Imagine you're looking at the typical parking lot of Walmart, right? That's as the prime example for first observation. And you look at it at 10 in the morning and at 2 in the afternoon. And 10 in the morning, you see a red car, and then at 2 in the afternoon, let's say it's a blue car. There's no way to know what happened in between. You have these two snapshots, and there's simply no way, because what you're looking at is a discontinuous variable, and the model you would need to build to actually physically, properly, and not statistically, but probably build all the steps in between, that is a highly complex model. That is not an easy model to do, right? Could be a yellow car, no car, truck, whatever, maybe a clown walking around in a clown costume. You simply don't know. Now imagine you're taking a temperature of, let's say, a house at 10 in the morning and then 2 in the afternoon. You can now interpolate between 10 and 2 in the afternoon very easily because it's a continuous value. You know there's not going to be a sudden jump, right? But there are a lot of models, and this is the base for all our weather models, where you can go from one temperature to the other, and you have a diurnal circle. And luckily, as humans, over the last 50, 60, 70 years, we understand this diurnal circle really, really well. What does that mean? That means if you're going into the thermal domain or any domain which is looking at a direct measurement of a physical variable, you can suddenly, which is following physical laws, and I know I'm simplifying here, you can suddenly interpolate. So not every data point you sell, it needs to then be generated by a satellite. And this reduces the cost by about a factor of 100 for some use cases, not every single use case. And suddenly you go from 90s music industry, that's what I usually refer to existing Earth observation companies, like, hey, you want to see this one little piece of that scene? You need to buy the entire scene, right? So you want to listen to that one favorite song? You need to buy the entire album. That's shit, right? It's not a good business model. And we're going to Spotify, like on pixel level, on demand, paying just for what you need. And it's super, super cheap. And that is going to be the game changer in Earth observation. But it doesn't work with every single spectrum. You can't easily do this in visual. You can't easily do this in SAR. And now coming to one of the questions you asked before is like the person on Lakestar side, he came into the office and within the first 50 minutes, he's grasped why this is different. And that's the reason Lakestar invested. That was Stephen Jacobs. Very smart dude.
Nice. Yeah, we know him. Yeah. Yeah. Nice.
So this is the reason I invested in the end, because we're just different. Yeah. Obviously, we can talk about what happens in between 90s music industry and there's Napster, obviously, right? Let's maybe skip that chapter. But we see ourselves as what Spotify changed in the music industry.
Yeah, and I remember that you pitched that idea to me in Paris at the World Satellite Business Week. Was it last year or the year before?
I think it was last year.
It was last year, right? Yeah, exactly. Very early, and I was pretty excited about that because I mean we procure a lot of data, and the business model is very disruptive, very innovative, right? And that's why we were always really excited to at some point in time consume your data. So maybe can you share us a bit where you're standing today? Because I mean we could see you launched 2 satellites. Right, but
yes.
Can you tell us a bit how that went and what did you do before these 2 satellites were in orbit?
Okay, I think I was just picking my nose.
Commercially, of course.
Okay,
how did you survive?
Yeah. How did we survive? So let's take the tension a little bit out. So data surveillance this month, right? So we can talk.
Nice.
It's looking. I mean, you maybe see it on LinkedIn. We send an image of the week every week, but we need to make sure that it's really fully properly calibrated, and we don't just give you some data, but it's the best data you can get, and that's the promise, and we make sure this promise will be kept. So how do we start? Well, first we had the idea, PowerPoint slides, and then we thought, well, if we go for agriculture, maybe before sending out a drone doing something else, we just buy a detector, and what we'll do is we just do some experiments and look at heat stress. So we actually try to grow maize in our office. Now imagine a bunch of a dozen engineers trying to grow corn or maize in the office. That went really well. Yeah, no, the maize didn't survive. We had an ant infestation. The whole office was halfway not usable anymore. It was horrible. And that didn't work so well. Then we thought, okay, let's use a drone. So, and we did all these things in parallel, right? So this was not necessarily sequentially, but the first negative results we had. So we thought, okay, let's use a drone. We spoke to a farmer in Spain. We had a partner company there, and we asked him to prepare 4 fields exactly the same. I think it was broccoli or something which my kids hate. Actually, it doesn't. 2 of them hate it, 2 love it. So it was broccoli. Then we said, okay, one is only you do whatever you do on this one field, and the second one we use the best IoT sensors there are, and the third one we use existing satellite data, and the fourth one a thermal drone, and then we just see which field performs best. After a lot of investment, time-wise and money-wise, we came back, and the results were completely inconclusive because all the fields performed exactly the same. We're like, this can't be, right? How is that possible? So we talked to the farmer, and he says, "You idiots. You tell me prepare the fields exactly the same way, and you give me different instructions for every single field." So I treated them all the same. I'm like, oh, fuck it. Yeah, I mean, yes, we're stupid. We should have explained better. So that didn't work. Then we thought, okay, let's do an airplane mission. So we had fields in Brandenburg, this time properly explained to the farmer. We had every single plant of maize. We had actually attached to a little pole, which was put in the ground. And then the idea is we fly over it with the airplane once, then turn around, cut all these stems of the maize, and then fly around as often as we can until we see stress. And the idea is that from literature, it should happen within 20 minutes. And this would give us an idea of how much advanced warning we get. The airplane was broken. The camera didn't fit. Then the pilot lost his license. The other pilot went into, not because he was drinking or anything, right? Just lost the license.
Yeah.
And the other one, I think, went into retirement. We are 3 months late. The maize was harvested, and we then just left in Berlin. Again, not really a lot of results. So the fourth thing we did was sending something to the space station. So we had a long-standing history in cooperation with Airbus, and they promised us that we're going to be on their platform, which is
Bartholomeus, right?
Exactly.
Daniel also wanted to send something up there, but he started live.
I think they still haven't sent anything up there, right? So what happened is we built something. We had, I think, 15 months of negotiation because we are financed by the Exist technology transfer program with the Fraunhofer, and then Fraunhofer and Airbus had to negotiate a couple of things that they basically couldn't agree on the general terms and conditions for 12 months. A week after we signed all this contract, they told us, Airbus told us, it's not going to launch in November, in April. We're like, 5 months, that's tough. That's a lot of runways. Like, no, not 5 months, 17 months. Not the next April, but then after it's like, what? It can't be, right? So we'll be dead as a company. So we again escalated massively, and then we eventually spoke with DLR, and they said, we told them, do you know they have 1.5 years of delay? And I said, 1.5 years, they have 6 years delay. We're like, what? Yeah. So then we asked them, and they did so nicely enough. We asked them, can you please just sublease this contract to someone else? So they subcontracted it to someone, Nanorex. And then we had 11 months from starting from scratch, because it was a complete different design, to go to fully functional orbit. And we only had 5 people back then. So we made it.
Nice.
It was crazy time. So eventually we went to the space station. We turned it on. It didn't turn on. We were devastated for 48 hours. And this is actually so many anecdotes now. Sorry for that. But
we wanted to ask you about the biggest fuck up moment, but I think you covered a couple.
We
don't have to ask this question. We saved that time.
Yeah. So this is now what was at least the most tense moment, I would say, as a company. It was in 2022, I believe. So after doing all that crazy stuff for 11 months, and like there were so many things with import, export, like it was crazy. There were dogs involved and eggs, right? Like crazy. Okay. So you eventually made it. And the astronaut put all these things together, built it all together, the robot arm took it, put it onto the Nanorex module, switched it on, didn't work. Fuck. So then we said, can we maybe repair it? Can we bring it back in? And we see what the analysis is, do a root cause analysis. And said, yeah, but it's normal rates for NASA. NASA rates has just increased from, $25,000 per hour to $120,000 per hour.
Ouch.
Yeah, that hurt a bit. That's not what they earn, right? Just what it costs, right? Otherwise, I would have already applied to be an astronaut. And then we did a quick budget calculation, like, okay, we have budget for 7.5 minutes. So that was not good. I said, okay, what can we do in 7.5 minutes? It took like 45 minutes to install it. And there's no way. After 2 days of basically not sleeping, and Marius, my co-founder, who has wearing a technical hat, he was devastated. He was probably the most devastated after 11 months of just marathon sprinting. A guy walks past, IT guy with a t-shirt, it says, did you try switching it off and on again? It's like, oh yeah, that's something we can do in 7 minutes. So we called Houston and said, hey, switch it off and on again, maybe 2 or 3 times. And turns out the Wi-Fi driver of the space station was not updated and had a problem during the update. So there's a $1 trillion space infrastructure, and they forgot to update, the flipping Wi-Fi driver. It then worked. They then forgot that we had a relatively limited data contract, and instead of getting 1,000 pictures, we got 10 million pictures, which is nice.
Yeah, I think, I mean, for our listeners, that shows, like you don't accept a no. You have a lot of lot of resilience, and you always have to balance. Oh, we don't have enough money. Oh, we have this problem, but you just continue doing the stuff, right? And I
Yeah,
think
there's no other way.
it's
It's never a straight
there's
line.
yeah, you just don't accept it, right? And you just continue, even if everyone says no.
You need
So
to be
yeah,
crazy.
yeah.
Otherwise, it doesn't work.
Yeah, I mean, we talked so often already. I hear this story for the first time. So really, really exciting. So then I checked our emails before, right? You invited us back then to the launch event for this one. We also got an image from the ISS from you guys a couple of years back. But then this year, your satellites launched, right? So how was that?
It was just the best. It was just the best. It was perfect. So we launched the first satellite in January, the second one in June, and it was just so good being there. I mean, this is an advantage for space companies, right? As a software company, you have your product launch and so on. But as a space company, which actually puts stuff into orbit, everything, all your work of years accumulates in a few minutes, right? Everything goes to the one point. There's no way to call Eden and say, hey, can you please delay the launch by a few weeks?
Yeah.
It's just not going to happen, right? So you need to be on time. There's no delays can be accepted, or maybe you can go to another launch, right? But that's usually a bit tricky. Everything, all that work accumulates in this few minutes where the rocket is launching. And just seeing that is such a privilege. And seeing how the team then jumps up, and it's outrageous. Was definitely a very, very, very memorable day. And I've very fond memories of the first launch, and the second launch too. Is just, if you ever have the chance to build something, stand it up with a rocket, do it. It's an amazing feeling. I have to be very careful with what I compare it. Obviously, the birth of my children was also nice. Yeah, but no, it's crazy. Maybe I didn't put as much effort in that, but let's not go down that route.
Incredible. So we already mentioned one other company which building, or two. We already mentioned two companies building other thermal sensing satellites companies. So Aurora Tech, Satellite View, there's Albedo Space, there's Hydrosat. So what differentiates you from these companies?
Yeah. I'm obviously slightly biased, right? So, and probably the answer we're better, it doesn't really, is A, not true, and B, probably doesn't really satisfy anybody. But technically, it's one thing. Technically, I mean, you can talk about resolution, all these things, right? But technically, it's accuracy. So we're the only company which can actually deliver high accuracy temperature. And why does it matter? If you take a picture with your mobile phone, it doesn't really matter if you hit the green of that car perfectly or the blue of the desk or whatever. That doesn't really matter, right? If you do physical measurement, it does matter, because you need to be able to compare, especially for this interpolation approach I mentioned earlier. You need to be able to compare today with tomorrow and yesterday, or like 3 hours in the future and 5 hours in the past, whatever it is, right? If you can't compare that, so if you don't have the absolute accuracy, you can't work that concept. So, and for that, to achieve that absolute accuracy, you need a certain combination of software, but also hardware. And we're the only ones in the market who actually has that combination, which is putting us in a nice position, right? And just to give you an idea why this matters, right? Give me a few ideas. Imagine, look at a pipeline, right? And the flux of whatever goes through, let's say it's oil, of that pipeline depends on basically the pressure. And the pressure has a direct representation by temperature, right? So if you increase pressure, you will increase the temperature. So if you cannot have absolute accuracy, if you can only see relative changes with an image, you can see if there's a leak. That's an important information. I agree. If you have the accuracy, you can tell exactly how much oil is flowing through the pipeline. That is a very different level of information.
Yeah.
And this is true for a lot of things. If you look at, let's say, I don't know, let's go agriculture, for example. If you look at hazelnuts in Turkey, they are extremely sensitive to frost. Knowing that there's an area which is colder doesn't really help you, right? You would need to wait for the harvest before that happened. But if you actually know that, hey, this was -5 degrees for 6 hours, suddenly, or same with hops or whatever in beer production, right? So if you actually know the absolute temperature, you can directly predict yield. Again, very different level of temperature. And just nobody else has that, because they don't have the cryocooling, or they only have a single channel, or they have a uncooled microsatellites, whatever it is, or they don't have the resolution. So we specifically set out to solve this problem, and it's all accuracy based, which is uncommon in Earth observation, and maybe therefore mostly overlooked.
I would have just one quick follow-up question to that, because exactly, I think the absolute measurements, that's super important. And I think, yeah, from what I know from these other companies, their pitch is different, right? We identify there's something happening, or this is hotter than that, or this is suddenly hot and was cold before. Not so much this is that temperature. You've mentioned though a lot of use cases in the agricultural space where maybe spatial resolution is not that important, but you also mentioned a couple of other use cases in defense, dual use, urban monitoring, and so forth. So what's your spatial resolution?
So spatial resolution native is 30 meters, but we do have a 5-meter camera on board in the visual for non-dynamic scenes. So the emissivity doesn't really change on the short timescale. We can use that camera to do super sampling, hence going down to, in the first step, it will not be 5 meters, right? So we're working on a 10-meter project and eventually it might become the 5-meter project, but that's the idea. And this approach is quite interesting because with next generations, we're then looking at 1-meter resolution. That's going to be really, really interesting.
Yeah.
So probably native around 10 meters, maybe 10 to 15 meters, eventually sub 10 meters. But if you then look at super sampling, you're going down to a single meter.
Yeah, but also...
And that's a very nice capability, which usually only classified systems have, which is slightly more expensive than what we have.
And again, right, a temperature being a continuous variable, there's also like, so within that pixel, right, like things don't jump suddenly. You can make at least some
and just to dive in there for another minute, right? So I said this Google Earth on steroids at the beginning, right? So imagine you have this digital twin of the entire planet, which gives you a continuous high resolution image of the world's, let's say, most dynamic variable, not the dynamic duo, just the dynamic single, mono, whatever, a temperature. And you could query this thing. Now with the capabilities we have with AI, you could start querying that thing. So you can ask, okay, what's the production level of oil in the Middle East? And then if you just know what are all the AOIs of the refineries, and then you cross-correlate this with, let's say, all the oil which is transported through these underwater, overland pipelines, which you can also measure, suddenly you know what the production level is. Okay, so this can directly impact oil prices at the other end of the globe. You can query these things like, hey, let me know, I don't know, anything in agriculture. Look at, are there any anomalies in power plants at the moment in North Korea, or whatever it is, right? This will become an indispensable, important strategic tool for decision making. And yes, we are still a bit away from that, right? It's not going to happen this weekend, probably also the weekend after. But the point is that if you combine, and this is probably the exciting part where we are, and which also differentiates us, and I say us as Livio and Orotech and Constellr, as the, let's say, the new players, the second wave of new space companies, which have learned from the first wave, and which are now seeing this marriage of Earth observation data, massive data layer, and AI. It needs good data. Hence, again, accuracy is important, right? And this marriage would enable so many implications we can't even think of yet. So that's going to be crazy. And this is the first time, including the interpolation and so on, where the cost will drop by 2 orders of magnitude. And suddenly, this is commercially scalable. And I think we're just before that threshold where this happens. And then it's not only going to be government business.
Yeah, well, 100%. Specifically when it's about invisible, to the human eye, invisible changes, where an image analyst can't really understand this AI and all the things with self-supervised models which are happening right now will help us here, right? I'm also really pumped about the coming 10 years in our industry. But maybe one topic we wanted to cover is the satellite quickly, because your evolution was from the ISS sensor that delivered like 100 to 300 meter, more like a Landsat.
I think was, what was it? 80 meters, I believe. It was 80 meters.
80 meters at the end, okay. And I remember you saying that this was mainly just showing that you can deliver Landsat quality way, way, way cheaper, right? Now the second the first satellites with up to 10 meter, the next generation potentially upsampled or sharpened to 1 meter. So that shows the evolution. But so your satellites, right? They are a bit, they are bigger, for example, like Robotech. Can you tell us a bit like the mass? The most important question for us is like, what do you do internally and what do you outsource, right? What do you focus on? Because you started this company from scratch and it sounds like a new innovative sensing technology.
Yeah, satellite mass is between 100 150 kilograms. So I think Sky 1 to around 120. And this might still change a little bit as we go into second generation. What do we do internally? So internally, we concentrate on our core USP. And that's everything around the actual instrument. Everything from payload design to eventually might be manufacturing, AIT, to the data processing and so on. But if there's some things like georeferencing, which is a well understood challenge and has been solved for some, we have zero ego about this. But everything which is touching our USP, which is delivering the highest grade temperature data which is commercially available, then we do it in-house. This right now ends at, let's say, low-level analytics. And then for that, for anything which is going beyond that, we are engaging with partners, but this might change at some point. However, not for things which are heavily relying on data merging, but on use cases which are very, which are substantially depending on a single USP, which is this highly accurate temperature data.
And on the hardware side, you also have a partnership with OHB, right? Like
That is correct. Exactly.
how is that helping you? Because I mean, they are the number one company in Germany, right? I mean,
Yeah.
Airbus is the European one, so.
Yeah. So OHB was one of our earliest investors, right? They also saw the potential there, and they built the payloads. They together, our team was a co-development with OHB, but we definitely learned a lot from their expertise for the first two, and now we're building the third one together with them. Yeah. No, it's that's. I think it is a good example of how, let's say, our approach is probably a bit more agile. It can still be combined with someone who has just massive industry experience and has built these things before. And I think there has been learnings on, wasn't always easy, right? But has been learnings on both ends. Really valuable.
Yeah, super interesting. And again, a lot of things which we would love to dive deeper into, but looking at the time, switching a little bit the gears here, right? You've mentioned all the different kind of like pre-steps you had to take to come to the point where you currently are. Now you're selling data. How have you been approaching your go-to-market so far, right? We know that you have some governmental anchor customers, such as the Copernicus contribution mission. I think also agreements with the German Aerospace Center. How important are these, and what are other elements of your go-to-market at the moment and going forward?
So go-to-market is obviously this data doesn't exist yet, right? Or it didn't exist until very recently. So there's a lot of education needs to be done. And what we have, let's say, two departments, two business units. One is looking very much at the commercial side with a focus on agriculture, but also analytics companies. And the other one is looking at the governmental market. And this is something which we've been focusing very much over the last 6 months and will be focusing very much going forward. So these are two distinct teams, which very different, let's say, approaches, because if you're selling to a government, you're part of the Copernicus contributing mission program, there's the ESA third-party mission, there's DLR contracts and so on, the CNAS contracts, and then we're speaking about two different other governments. There's the civil side, then there's also the non-civil side, and this again needs very different approaches. To give you one example, when you're speaking to MODs, you usually speak about capabilities, not so much about, hey, there's this certain use case I'm happy to solve for you. It's more an overall capability to do X. Let's say the capability would be an advanced warning across your borders, or advanced warning when it comes to vessel detection, and so on and so forth. Does it answer your question?
Yeah, for sure. And I mean, over the last couple of months and years, the governmental side of things have gotten another spin, right?
Specifically
Yes.
here in Europe, right? We were always lagging the US, right? I mean, we are still behind when it comes to the sheer amount of governmental contracts, right? But do you see a change right now in Europe?
Especially if also maybe with the twist of the defense, kind of like a boom in the defense industry, which we're seeing over the last few months.
Yes, absolutely. There is so much interest. So just coming back from vacation and now diving into the governmental sector, we have so much interest. Like every week, we're speaking to military attaches, we're speaking to MODs and so on. As we dig deeper, obviously different countries have different levels of knowledge on how to use that type of data. Some countries like France have their own systems which are classified, or at least partially classified, and have a lot of knowledge. Others, for them, it's still relatively new, so it's in exploration on both ends. But we definitely see that there's a lot of momentum, and in some cases, money seemingly becomes less of an issue. But we still have to be convinced that this is really the case, because obviously now everybody is branding him or herself or itself as a defense company. And this might be confusing at times.
Yeah, that's true.
So, I mean, yeah, we could, if we would have more time, we need to do some Joe Rogan type of podcast for 3 hours at some point in time. You are one of the shortlisted candidates, but maybe now thinking about where you are standing right now, right? So we see, okay, you have 2 satellites in orbit, right? You are one of the new space waves, like we at Live here, right? Which are there. When it was very hard at the early beginning, now everyone is talking about space, which is very good. We have a ministry. So I'm interested to hear your perspective of what's next, right? You see this increasing demand, so you will have a lot of tailwind. You have systems in orbit which others don't have. Sounds pretty exciting. So what for you is coming in the next 5 to 10 years? How many satellites will you launch? And what's your big...
Next 5 to 10 years. Looking at the past, my plans is, I'd say on a large scale, they usually worked, but on the smaller scale, not so. But what's the next steps? Next steps is we need to continue investing in innovation, right? So I'm already said, okay, it's going to be second, third, and so on generation. So it's really step one is establishing yourself as Joe would say the Platzhirsch. So the number one player when it comes to thermal data globally, and then spreading into different sectors. So going really deep into some verticals and then spreading horizontally. And also making sure that we keep at the bleeding edge of what's possible. And my goal is to build, well, let's say 10, 15-year time frame, to build a system which is basically the queryable, digital twin of the planet, which does not necessarily only need to have thermal data, right? Other data is very likely to be ingested. And building that would be an exciting thing because that would completely change how we see our planet.
And with that, obviously, you would have an incredible impact on the future and also on also many industries. So again, I can just second what Daniel said. We could spend hours here talking, and I'm still up for having a podcast with all thermal satellite companies.
That'd be nice.
Yeah, and we have all the contacts, so we should bring them all into one massive episode and have one round table with some spicy questions.
Spicy questions. And we do it in an MMA ring. I love that.
Exactly. Yeah. But that really brings us to the end, unfortunately, today. But obviously, as we always end the podcast, who should we bring on next time?
I think an interesting character, but it might be that you already had him, would be Bullet.
We had him. We had
him already. Did you have Klaus Hummels?
No, we did not. So that would obviously be great. Yeah.
Perfect.
Because he's a very interesting person, first of all, general. He is obviously not really a space veteran, but as we said, right, Lakestar started doing new space investments with ISAR and with us. And I think he has an interesting perspective. And sometimes it's good to have non-industry experts to share perspective because we are all living a little bit in a bubble. 100%.
I think that would be a great guest. And I think really fits well also with the subject of kind of investments in defense in Europe, which he's very deeply involved in. So I think that would be a great podcast guest. But that's for the next time. First of all, obviously, thanks, Max. That was so interesting. Thanks for sharing all these anecdotes from your past. Really incredible. And I think this podcast episode is asking for another one in the not too distant future. So thanks a lot, Max.
Yeah, it was my pleasure. Sven, Daniel, thank you so much. And looking forward to meeting you guys in Berlin or in Paris or wherever we meet again.
Yeah.
Perfect. Yeah. And for our listeners, also thanks so much for joining today. So check out also Constellr if you want to buy some thermal data, right? But also connect with Max Constellr through the links below, which we will share in the description of the podcast. And yeah, tune in next time. And of course, also follow New Space Vision on all the socials, Twitter, Instagram, Facebook, YouTube, LinkedIn. And I'm looking forward to the next one.
Same.
All right, lift off and the clock is started. Liftoff. We have a liftoff.